Hello, my name is Mr. Mendoza, and we're going to be going over Chapter 1.1 Notes, in Geometry. This is absolute values. What I'm going to have you do is I'm going to have you put this in your notebook, and we're going to start this on page 7. So I'm going to want you to handwrite this into your interactive notebook for your notes. So when we're doing some worksheets, you have some notes to go ahead and reference. I will only assign you stuff that's from the journal, that's from our curriculum, and that's what I'll provide you notes with. So when you have any questions, just refer to these notes, and these notes should have some examples and some definitions that will give you a hand. So in your notebook, do the Cornell note template. We have the essential question, which is how do the values of A, H, and K affect the graph, the absolute value function? G of x equals A, absolute value x minus h, absolute value plus k, okay? So we're going to be going into transformations, translations of absolute values. And what we're going to start with is A. So if you want to go ahead and pause, this will be a good pausing moment to go ahead and put this in your notebook. This seems like a lot. I typed this something in Word. When it's all said and done, it shouldn't take you that long. If you want to pause it, and then we can continue. But after you put this in your notebook, start with the absolute value parent function. The parent function is the most basic form of this family of functions, okay? It goes at the origin, so I have some characteristics here. It's V-shaped, looks like a V. It passes through the origin. Domain, so what's the word domain? Domain is in terms of, I guess I didn't put it here, but domain are the x values. Okay, it's all x values. Basically means how wide it is. It means where the x values lie on this specific function. So in this case, if this arrow indicates that it goes for infinity in every single direction. And if that's the case, the domain tells us how wide this thing is, how wide it is. It's forever wide. And if it's forever wide, it means it includes all real numbers in terms of x. So again, this is going to be my x values. Okay, x values. Okay, I have some examples here. Parentheses, whenever you're doing notation for domain and range, parentheses means that it does not include the value, right? And there, I did not include it because we can never approach infinity. It's a concept. It goes on forever, so we can never hit. We can approach it, but we cannot actually touch and see infinity. So now we're going to be talking about the range, okay? The range means how tall, okay? Domain means how wide. This means how tall, and this refers to y values, okay? So if you're talking about how tall it is, okay, notice I have a bracket here. I have a bracket. Bracket means it includes, right? So here, this graph touches 0. So if it touches, it includes 0, and it goes for infinity up. So it goes for infinity up in terms of y values, okay? So we're going to say, oh, there you go. So there we go. So those are the characteristics of the parent function. And before we go to translations, we got to understand those basic characteristics of the parent function for the absolute value. Okay? So what I'm going to do now is I'm going to erase this. You can always rewind and go back and add some stuff. So what we're going to do is we're going to go ahead and graph and find the domain and range for this function here. We have h of x equals x plus x, the absolute value of x plus 1. Okay? So we're doing that next. Okay? To go ahead and find those points, we're going to make a chart. We already have one here. So x is going to be my inputs. Okay, those are my inputs. It's what I put into the function. Okay? So these go in here. Okay? Inputs, we put them in. What comes out is the result. We call it the outputs. Okay? And so if we make this chart here, all we simply do is we say, hey, h of x, okay? But instead of saying h of x, we're going to say h of x. We're going to say negative 2, okay, equals the absolute value of x. It's no longer x, because my x value is going to be negative 2 plus 1. Now, the thing about absolute values is that anything that goes in the absolute value gets turned into a positive number. Okay? So in this case, the absolute value of negative 2 is 2. 2 plus 1 is 3. So we have an output of 3. Next, what's my next input? Negative 1. The absolute value of negative 1, we know is 1. Right? Plus 1. So 1 plus 1 is 2. So my output is 2. We're going to continue this with the other ones. H of 0, the absolute value of 0 is just 0. So we get 0 plus 1, and it's going to be 1. Okay? So we put a 1 here. H of 1, the absolute value of 1 plus 1 is 2. 2. So you can notice, you can also go ahead and back and say, hey, some characteristics of absolute value is it has symmetry about the x-axis. About the axis of symmetry, about the x-axis. So if we look at these, the following values, you can kind of fill it in. It's going to be 3, right? We'll do one more. Absolute value 2 is 2. 2 plus 1 is 3. And then all we do is we go ahead and graph. You can go ahead and, I got this from the interweb, and we just go ahead and plot our points, okay? So max value. Max value is 0, my x value, and my h of x is my output, which my y value is going to be there, okay? Next going to be the x value of 1, 1 and 2. There it is. X value of 3, 3 is going to be, x value of 2. X value 2 is going to be, output's going to be 3, okay? On the other side, we're going to have negative 1 for my x value. So negative 1's there, and my y value is going to be 2. So I go negative 1 and 2. There it is. Then I go negative 2. Negative 2 for my x value. What's my y value? Well, it's 3, so I go there. Okay? So then I go and I just connect my dots, and I make a graph, and there it is. Okay? It's a V shape. Let me see if I can make this dots a little better so you guys can see. There we go. Okay? So that's absolute value. So notice that this has been changed. It's no longer at the origin. Okay? Something that we did to it affected where it went to. So we have h of x equals x, the absolute value of x plus 1. So that plus 1 made us move it from the origin, right from the origin, up 1. Okay? So now we're going to talk about the domain and range. So domain, okay? Domain means how wide. How wide is this? Well, it's going forever. If it goes forever, guess what? It's going to include all x values, from negative infinity to positive infinity. So we can say domain is going to be from negative infinity to positive infinity, or you can say all real numbers. This is the symbol for all real numbers. And R in 2 lines. Okay? Range. Okay? Okay, how tall is it? Okay, how tall is it? And again, this is in terms of y values. Range is y values. Domain is going to be x values. So how tall is it? Well, let's look and see where it starts. Where does it start in terms of the y values? It starts at, and it's hard to see, but it's going to start at plus 1. Okay? So if it starts there, in terms of height, how tall it is, we're going to say that it's going to touch 1. The value of y is 1. It's going to touch there, and it's going to go forever up, right? In the positive direction. So the range is going to be from 1 to infinity. From 1 to infinity. Okay? I'm going to go ahead and erase this, and we're going to do one more problem. So if you want to go ahead and pause this and then record this down, go ahead and do so. Okay, we're going to do something very similar. We're going to keep it basic, but notice that our function that we're going to go ahead and graph, we're going to graph h of x equals x plus 1. Okay? So in the other one, we had the 1 on the outside. Now we have the 1 on the inside. So let's see what's going to happen here. Okay? We're going to apply a transformation. We're going to apply a change to this. And we have these inputs already solved for us. And so we're going to see what's going to happen. If we already have this solved already, I already did it for you, then we're just going to go ahead and go straight to graphing. Okay? But you know what? I'm just going to go ahead and do it anyways. Why not? H of x. Okay, we're going to start with -2. Okay? That means that our x value now becomes -2 plus 1, absolute value. -2 plus 1 is -1. The absolute value of -1 is just 1. Okay? Our next input, again, inputs, outputs, right, is -1. So again, what used to be my x value? It used to be x, but I'm saying I'm going to plug a 1 in. So my input's going to be -1. So what's -1 plus 1? It's 0. The absolute value of 0 is just 0. Let's put a 0 there. Next is 1. I'm sorry, it's 0. H of 0. Okay? 0 plus 1. 0 plus 1 is just 1. The absolute value of 1 is 1. Next is h of 1. So we have 1 plus 1 equals, sorry, the absolute value of 1 plus 1 is 2, which is just going to be 2. Okay? And then our last input is 2. Each of 2. So absolute value of 2 plus 1, okay, which is 3. Absolute value of 3 is just 3. Okay? If we have all those points, then we can go ahead and plot. Okay? So we're going to start, let's just start -2 for my x value, which is going to be here. -2. It's hard to see. Just make your own graph if you can't see. Again, that's going to be -2, -1. So I'm going to be at -2, and then my output's going to be 1. There, my first point. Okay? My second point is going to be -1, -1 and 0. Okay? -1 and 0. So -1 and 0 is there. Okay? Negative x value of 1, and then a 0 value for y. Okay? We're going to keep going. Let's see here. Next, we're going to have x value of 0. X value of 0 and a y value of 1. There we go. We have now an x value of 1 and a y value of 2. So we go there. Okay. Now we go here. An x value of 2 and a y value of 3. Okay. Now, because now we know that the vertex is where the absolute value changes direction. And we know that absolute value functions have symmetry. Okay? They're symmetrical. They're mirror images. I'm going to test out my purple marker for the first time. Symmetry means that the vertex is a mirror. A mirror. This x value is a mirror for all my points. So if I have symmetry, it's safe to say that this point has a mirror point on this side. It's safe to say that this point over here has a mirror point on this side. We can check it. We can do a few more. So what I'm going to do is I'm going to erase some stuff because I'd run out of space. I'm going to erase the first two. And I'm going to add some points. I'm going to add -3 and -4 as my outputs. So what I'm going to do is I'm going to add -3 and a -4 for my outputs, so I can try to complete my graph, so I can prove the symmetry. Okay, so I'm going to say h of, I said -3, right? Equals, what's my input? -3 plus 1. Okay, The absolute value of negative 3 plus 1 is negative 2, right? So we can say the negative 2 absolute value is 2. So then I can say over here is a 2. Okay? Let's do the last one. H of negative 4. H of negative 4, okay? Absolute value, my input is negative 4 plus 1 equals 2. Absolute value. Negative 4 plus 1 is negative 3. Negative 3. Negative 3, absolute value of negative 3 is just 3. So we have 3. So now we can go ahead and try to complete our points here. So for the x value of 3, right, the input is 3, negative 3. Our output is 2. If our input is negative 4, our output is 3. So again, absolute values, absolute functions have symmetry. So if you do a data point like this, and for whatever reason you don't have the nice points, just use the characteristic of symmetry to simply fill in your other points. Now we can simply go ahead and fill in our line. Okay? We're almost done. We're going to do domain, and we're going to do range. Remember, domain is our x values. It tells us how wide and how wide the function is. Okay? But you can see there it's forever wide. If it's forever wide, it means there's going to be an x value that's going to exist on this line forever, infinity, right? And positive infinity. So again, round parentheses means it does not include the value. So negative infinity to positive infinity. My infinity values are not that great, I'm sorry. Range. Let's see how tall this is. Okay, let's see how tall it is. Again, and this is going to be my y values. Range is y values. So when we see this, we see how tall is it? Well, where is the y value that this function starts at? The y value that it starts at, the low point is 0. And it does include the 0. It does include the 0 low point. Okay? So we say 0, and it goes for infinity up. Okay? Infinity. There it is. Okay? So there's that. Now we're going to move on to some stuff that's going to be a little more challenging. This is where most of the frustration comes into play on this next part of our notes. We're almost done. But if you take my advice and really spend a lot of time in this next section, you will save yourself serious time down the road. Okay, if I was to say anything, this would be probably the most important thing here, is this chart here. This is going to tell us, it's going to answer the essential question. What does A do to the absolute value? What does H do to the absolute value? And what does K do? All right, we already did in H. You notice that we shifted the graph left and right with the H. You know that the K value is responsible for going up or down because we did that already, right? So for the first one, we put a value on the outside and you made the function go up or down, okay? It means the V went up or down. If we put a value on the inside for the H, then you have the graph and you shift it to the left or to the right. So right away we have two transformations, right? This goes left or right, depending on the value. This goes up or down, depending on the value. And again, these are listed here. I hope you guys can see them, but if not, I'll put a document on the module so you can have access to these notes. So with this being said here, we're going to start here. Absolute value function in vertex form. Okay, it means that the vertex is HK. That means where the absolute value changes directions. So really at the base, right? Now it can open up or it can open down depending on the A value, and we'll get there, okay? So values of A, H, and K apply transformations changes to the graph itself. So the rule here says if the H value, if the H is, if it's minus H, right? If it's negative, then the graph goes to the right. We shift it to the right. If it's a plus sign here, the graph shifts to the left. Okay, those are the H values. That's what the H's do. The K values, what do the K values do? Well, if it's a positive K value, it goes up. Okay? If it's a negative K value, guess what? It goes down. Okay? And we just did that in the previous two examples. We just did them separately. Use Desmos. So if you don't have a graphing calculator, use Desmos. It's a free graphing calculator on Google Chrome, and it's great. Use Desmos or graphing calculator to check answers for the following examples. Okay. So notice here, describe the transformation. Well, guess what? It's -3. Okay, it's -3. So if it's negative, which way are we going? We're going right. So we're going to say shifted 3 units, and you can just say an arrow to the right. 3 units. 3 units to the right, we shifted. Okay, next one. G of x equals x plus 3. Describe the transformation. Well, guess what? It's plus. What do you say plus does? It goes to the what? It goes to the left. We're going to say 3 units to the left. Now we have on the outside. Okay, on the outside. What does this number correspond to, huh? It's on the outside. What's on the outside? It's my K value. My K value does what? It makes my graph go up or down. So here, if it's -3, right? If it's negative, it makes my K value, right? It makes the graph go what? Down. So we're going to go 3 units and then down. Next, we have same thing, but my K value is what? It's positive. If the K value is positive, it goes up 3 units. We're going to say 3 units up, just like that. Okay? And now we get to the part where we're talking about the A value. Okay? The A value is the slope. You can't see it here. The vertex. The A value is the slope. It tells you either how narrow or how wide the absolute value is. So we're going to go and describe the lower one. Give me a chance. Go ahead and pause if you haven't finished. We're almost done here. I'll try to make my future videos a little shorter, but this first unit is so important, and it's filled with a bunch of important information. So we're on number five. Describe the transformation. Okay, so you didn't see it before, or it should be up there. But if the A value, okay, if the A value is going to be greater than 0, greater than 1, right? If it's greater than 1, it's going to be stretched. It's going to be narrow. Okay, it's going to be narrow. If 5 is going to be what? Is 5 greater than 1? It is. So if it's going to be greater than 1, then it's going to be a vertical stretch by a factor of 5. Guess what? A is what? A is smaller than 1. If it's smaller than 1, right? If it's smaller than 1, then it's going to be a shrink, which means it's going to be wider. So it's going to shrink it. And it makes sense because here my slope is 5, which means I'm going to go up 5. I'm going to go, for example, if this was my graph, okay? If this was my graph, just saying. You don't have to write this down. If this was my graph, if I go up 1, 2, 3, 4, 5, and then over 1, guess what? Steep. Compared to a slope of 1. If it's just a slope of 1, it's up 1 over 1. Up 1 over 1. So if you were to go ahead and compare the parent function with this function, right? This one here, the darker one, with a stretch factor of 5, is much steeper. because the slope is greater. We're going up 5 and over versus going up 1 and over. So you can see the difference. The slope changes how narrow or how wide. So here, my slope is 1/3. Okay, so I'm going up 0.3. Up 1/3, right? So, by a factor of, this is going to be a vertical stretch, it's going to shrink it by a factor of 1/3. Okay. Let's see here. The value of slope, the value of A slope, okay, the value of A equals slope. Okay, so again, A equals the slope. It tells you how fast, how steep, or how narrow the absolute value function is. If it's positive, okay, I'm going to do the parent function here. Let's say this is going to be f of x equals the absolute value. Okay, that's positive. Okay, my A value is positive. There's nothing there, but you always assume there's going to be a 1 there, right? If we assume there's a 1 there, the slope is just going to be up 1/1. Up 1/1. Okay? Now, if it's going to be, let's do a different one. Let's do, we're going to call this g of x because it's a different function. G of x equals absolute value of x. But you know what we're going to do? Oh, you guys can't see, so I'm going to go ahead and put it somewhere else where you guys can see it. So this function is opening down. I'm going to say this is going to be g of x equals the absolute value of x. But guess what? It's opening down. Why is it opening down? Because the slope is negative. Whenever you have a negative A value, the graph opens down. Okay? So, A is a slope. It tells you how fast the slope, how fast we rise. So hence, how narrow, right? How narrow, or if we have a small value of slope, it's going to be very, very narrow because the rise over run is going to be a low value. If it's a positive, we open up. Okay? We go up. It's an upward trend. If the graph is opening downwards, it means that the A value is negative and it opens down. Okay? Hope that was helpful. If you have any questions, please let me know.